We're asked to use the data below to write the rate law, and we're given the balance equation for this reaction. Rate laws are written in the form rate is equal to the rate constant, which is lowercase k, times the concentration of the reactant, in this case is dinitrogen pentoxide, raised to some power. And we'll just call that x for now. So to determine the order, we need experimental data. So in trials 1 and 2, let's compare how changing the concentration changes the rate of the reaction. Because the rate law gives us that relationship. Rate versus concentration. So the question we're asking is, when we change the concentration of a reactant in a reaction, how does that change the rate of that reaction? So let's compare what happens when we double the concentration of the reactant. Notice when we double the concentration of the reactant, the rate also doubles. So when we double the concentration, we get a doubling of the rate. So 2 raised to what power is 2? So x is equal to 1, and we can say this reaction is first order in N2O5. And because that's the only reactant, you can say this reaction is first order overall. So the rate law for this reaction can be written as rate equals the rate constant times the concentration of N2O5 raised to the first power, which we don't write ones. It's important to note that the order does not come from the coefficient in the balanced equation. A second way you can get the order is by writing the rates as a ratio. I like writing the larger number on the top of the ratio because then I'll get, pick a different color, then I'll get a number greater than 1. So I just copied the data and rewrote it in this ratio. So I'm going to simplify, and you get 2 is equal to 2 to the x. And again, you get the same result. 2 to what power is equal to 2? So x is equal to 1. Therefore, it's first order with respect to N2O5.